Brazil is becoming the second largest reserve for rare earth, and mostly they are ionic clays. And Excel is actually an ionic clay rare earth hosted system. It is very amenable to the in situ recovery. Not many ionic clays are amenable to in situ recovery.
Hello, you're watching Proactive. I'm joined by Excel Re Managing Director, Dr. Patience Mpofu. Patience, very good to speak with you. For investors new to Excel Re, what's the opportunity at your Caledon project in Brazil?
Thank you, Stephen, for having me today. There are many opportunities that Excel provides for new investors. I think let's start talking about critical minerals. The world needs critical minerals, firstly, but they need, most importantly, the rare earth. And these rare earth are very critical for many countries. Why? Because they are in short supply, number one. Number two, they're mainly concentrated in China, and the world needs diversified supply chains. And what a better way for Excel to participate in this? The second point is that Brazil is becoming the second largest reserve for rare earth, and mostly they are ionic clays. And Excel is actually an ionic clay rare earth hosted system. It is very amenable to the in situ recovery. Not many ionic clays are amenable to in situ recovery. And I think that's one of the biggest advantages. And I will just take you through the advantages of the in situ recovery. Number one, you don't need high capital for the in situ recovery. It is because it's not your traditional conventional mining. Your traditional conventional mining needs high capital, it's got high costs, but most importantly, the environmental impact that it leaves is quite huge. For example, you need tailings dam. But with the in situ recovery, this is a very innovative way of extracting your rare earth. You do not need high capital, as I've already said, very low costs, operating costs. In fact, all you need is the magnesium sulfate and potentially your electricity. Those are your major costs that you have for your in situ. And then lastly, when you talk about in situ recovery, no impact on the environment, minimal impact. So when you talk about responsible mining, that's in situ recovery. The fourth point that I would like to mention is that we are already de-risking the project from being just an exploration company to a developing and hopefully becoming a producing rare earth company. So at this point in time right now, we have already demonstrated that we can recover the ionic rare earth system through in situ recovery. We are already moving into the field tests. We've already demonstrated also on our column test. That's an important step because that shows that we can now emulate what happens on a diagnostic to the column, and we can take all those operating conditions into the whole field test. Lastly, Excel contains gallium. Not many ionic clays contain gallium. Gallium is found predominantly and produced in China, and you can only find it in as a byproduct from alumina and other systems like the zinc. It's a byproduct, but we will be able to produce gallium. And strategically, this is very important for semiconductors. And in a nutshell, those are the major reasons why it's a huge opportunity for new investors to look out for Excel. Thank you.
Patience, you're talking about a low cost, low impact way of extracting rare earths. What competitive advantage could that give Excel?
Oh, absolutely. The first is if you think about when you get your resource from exploration to the time that you get your product. For a conventional mining, the lead time can be anything between 5 to 10 years, and that's for the hard rock. But for Excel, your lead time is very short. It potentially can be half that because you do not need to build huge infrastructure for your mining. All you need your magnesium sulfate, you need to build your well field to be able to then take your magnesium sulfate, inject it into the well field, and extract those rare earth. And your processing, we're talking of a 4-step processing. Once you get your pregnant liquor solution, you then remove your impurities. That's step number 2. Then you add in your magnesium carbonate, bicarbonate, to produce your MREC. Very simple process, no complication. So as I mentioned, low cost, potentially first quartile, low capital, high capital efficiency. Lastly, environmental impact, minimal. So those are the advantages in a nutshell of using your in situ recovery method. Thanks.
You mentioned the importance of gallium in the deposit, but the project also contains a high proportion of magnet rare earths, including dysprosium and terbium. Why are those elements attracting so much attention?
Oh, they are attracting a lot of attention. And I will tell you, the major reason is because in your basket, you've got your light rare earth and your heavy rare earth. Most people pay attention to the light, and we know from a pricing point of view, they have a higher price. But when you talk about supply demand dynamics, currently there's a huge deficit of the heavy rare earth like the terbium and the dysprosium. So looking at the supply demand market dynamics, the forecasts show that there will be a huge supply deficit. And we are lucky that our basket has a higher proportion of the heavy ones. And that's important because, as you know, all these are used in the magnetic, manufacturing industry, be it electric vehicle, be it the wind turbines, be it robotics, be it even, in terms of from strategic uses by countries who are using it for technologies for your defense. That is super important. And I think these positions Excel in a very good space because then we're able to close that gap.
You've moved from laboratory testing towards field trials patients. What's the key milestones investors should watch over the next 12 months?
Oh, absolutely. We are moving. Number one, it's about de-risking our technical work. So remember, we currently have an inferred resource. We are progressing to get to indicated, so we will be able to announce as we progress with our drilling. Secondly, remember we started with diagnostic, just to be able to say, are we able to use in situ recovery to get all these rare earth? And we're able to demonstrate at lab scale through diagnostic test work. And now we announce our column leaching test, and that actually emulated what happens in the field test. That's important. We were able to recover up to 560 ppm of our trio, soluble trio. That's an important figure. 39% of our embryo, which is your magnetic rare earth. Now going into the field test, this is now the real work, de-risking the project. So investors should be watching out for our field test that we'll be doing to de-risk and to show that we are able to do it in the ground. We will be able to collect all the data, hydrogeological data. We'll be able to show permeability in the ground. But not only that, I think our environmental baseline work will come into play because we'll be able to gather all the data. How are we impacting on the groundwater, which we shouldn't be able to impact? And all that work will be coming together. We'll be able to get all our design criteria for our engineering, and we'll be able to get all the information that we need to move us to the next step. And hopefully we'll be able to get our economic model, which is essentially our scoping study, and we'll communicate that in due course. And we're very excited about project. And remember, critical rare earth elements are the future. If you're using your phone, if you're using data, if you're using AI, it all needs rare earth. And this is an alternative. And Excel is participating in the critical minerals and is providing a competitive advantage in this space. Thank you.
Patience, I hope you'll keep us updated on your progress. Thank you very much for your time today.
Thank you, Stephen, for having me today.
That's Accel Re Managing Director, Dr. Patience Mpofu.